Hi, in this video we are going to understand about the bisection method. So first we will understand the concept and the theory behind the bisection method. Then we will see a working example which will tell us how the bisection method actually works. And at last we will implement this bisection method using a C program. Now before moving to the bisection method, let us understand some of the background things behind this method. So if I tell you in one line, bisection method is a method to find the roots of an equation. Now, when the equation or the expression comes, we should know what are the different types of expression available. So first type of expression is algebraic expression. So what are algebraic expression? So the expression in which each of the term is of the form like r x to the power r. Those expressions are called algebraic expression, and this r means a real number. So you can see here the expression can consist of many terms, term 1 plus term 2, term 3 and so on. So here instead of plus there can be minus also. So it can be like term 1 plus term 2 minus term 3 and so on. So if you see the example here, this simple 2, it is an algebraic expression. How? So if you write this 2 multiply x to the power 0, this is equal to 2 multiply x to the power 0 is 1, that means 2. So we can write this 2 in this r x to the power r form. That means this is r, x is the variable and this 0 is the exponent or the power, and this 0 and this 2 is a real number. Likewise, we have root 3. Again, root 3 can be written as root 3 x to the power 0. That means this root 3 is a valid algebraic expression because it can be written in the form of r x to the power r form. Likewise, all these terms are algebraic expression. Likewise, if you see this expression, so here each of the term is of form r x to the power r. How? So here this is 1 x to the power 1 by 3. So this 1 by 3 is something like 0.33. So this 0.33 is a real number. So this term is a form of r x to the power r. Then we have plus, the next term is simple x. So this can also be written as 1 dot x to the power 1. So again this x can be written in form of r x to the power r. So as each of the term in this expression is of type r x to the power r, so this complete expression is a valid algebraic expression. Likewise, this can be written as 4x to the power minus 1 and minus 10. So this minus 1 is again a real number, and this 10 can be written as 10x to the power 0. So this complete expression is also a valid algebraic expression. Now next type of expression is polynomial expression. So here each of the term in this expression is a form like r x to the power w, where w is a whole number. So you know whole numbers are 0, 1, 2, 3 and so on. All the counting numbers starting from 0. So these are the examples for the polynomial expressions, and if you observe, all these expressions are actually present in the algebraic expression also. But this expression and this expression is not present in the polynomial expression. So here if you see, like we have root 3, so we can write root 3 x to the power 0. So 0 is a whole number, right? So this root 3 is a valid expression, polynomial expression. Likewise, this is also a valid polynomial expression because all these powers of the variable x are the whole numbers. But if you see this expression, that is, so here if you see this 1 by 3 is not a whole number. So that means if any of the term in an expression is not following this form, then that complete expression is not a polynomial expression. Likewise, in this expression, this term is having the power minus 1. So minus 1 is not a whole number. So this expression is also not a polynomial expression. So we can say this algebraic expression and polynomial expression satisfy this relation. That is, all polynomial expressions are algebraic expressions, but all algebraic expressions need not to be polynomial expressions. Polynomial expression is a subset of algebraic expression. Now next type of expression are transcendental expression. So these are the expression in which each of the term can contain trigonometric expression, reverse trigonometric, log, exponential or hyperbolic terms. So for example, we have x square minus sin x. So this sin x is a trigonometric term. So this x square minus sin x is a transcendental expression. Likewise, in this expression, we have the term x e to the power x. So this e to the power x is a exponential term. So this complete expression is also a transcendental expression. Likewise, we have the hyperbolic term cos hx, or we can have sin hx. So this is also a transcendental expression. Here we have the log x. Here we again have the trigonometric term also and the exponential term also. So all these expressions are the example of transcendental expression. Now the question is, why we are studying these expressions? We are here to understand the bisection method. So the thing is, this is the actually background for the bisection method. So we know that we have some methods or the formulae to find the roots of the algebraic equation. That means, let's say we have this expression, x square minus 5x plus 6. This is a quadratic expression. And if I equate it to 0, and if I say that what is the root of this quadratic equation, you will say that 2 and 3 satisfy this equation. That means if I put 2 here in this expression as the value of x, I will get the complete answer of this part as 0. Likewise, if I put x equal to 3 in this expression, again this will satisfy it and I will get 0 in this part. So you can find the roots of this equation using the middle term splitting, right? Likewise, if we have this expression and we are to find the root of this equation, that means we have to find the value of x which can satisfy this equation. That means which can make this part equal to 0. We can simply say that x minus 2 and x plus 2 equal to 0. That means we know the formula or the technique to solve this type of equation to find the root, and we can say that yes, x equal to 2 or the minus 2 will be the root for this equation. So these are the simple equations for which we have the methods or the formulae available. But there is no such algebraic methods available to find the roots of higher order polynomial equation or transcendental equation. For example, we have this expression and the order of this expression is very large, that is x to the power 100. So this is a higher order polynomial equation. Now there is no methods or you can say algebraic methods available to find the roots of this equation. Likewise, for the transcendental equation, we have no algebraic methods available. So in order to find the roots of this polynomial equation which are of higher degree and the transcendental equations, we have to devise some methods so that we can find the roots of those equations also. So in order to find the roots of transcendental equation or the higher order polynomial equations, there are some methods devised by the scientist. And those methods are like bisection method, regular fallacy, iteration, secant, Newton-Raphson method, and there are some more also available. And these methods can also be called as numerical methods. And one important thing to note about these all methods is these all are approximation methods. That means these methods give the approximate value for the root which can satisfy our equation. So what is meant by approximation method actually? So here you can see a graph and this is the function which I drawn here graphically using this line, and these are the points 1, 2, 3 on the x-axis and this is the y-axis. So here you can see this 2, that means x equal to 2 is the value of root for this function because this function is cutting this x-axis at this point 2. So that means x equal to 2 is the root of this function. But when you will apply bisection method or any of these methods, you will not get x equal to 2 as the root of this function. You may get some closer value nearby 2. For example, you may get, let's say, x equal to 1.9, or you may get as, let's say, 1.922, something like that value. That means you can get any value closer to this 2. So you may get like 1.9 or 1.92 or so on. So that means you will get nearby value, not the actual value or the actual root for this equation. And you may also get something nearby value toward this side also, likewise 2.1 or something. So you may say that these methods are actually giving me the approximate value or the nearby value, not the exact value of the root. So why I should use these methods? So for this you should know where these methods are actually used. So we have the problems in the real world and we actually formulate those problems in the form of equations. So we can have problems related to something astronomical problems or some signal and system related problem, or there is some problem related to heat transfer between the two devices that is related to some mechanical engineering. So there we all formulate the real world problem in the equations form, and there we want to just know the nearby roots or you can say some approximation roots. So for that these approximation methods or the numerical methods comes very handy. So finally we can say bisection method is a method to find the approximate roots of a transcendental as well as algebraic equation. And this is a approximation method. That means it will give me the approximate root of a equation. And bisection method have some other names also, like Bolzano method, because Bolzano discovered this method, and interval halving method, incremental binary search method, because this method actually works similar to binary search method. So this name is given in with respect to that one. And the other name is dichotomy method. Now there is a note that you can see here. Bisection method actually applies to any continuous function for which we should know two values with opposite sign. Now what does it mean actually, that we will see later in the video, but we should know what is continuous function. So just to recall, this f1x is a continuous function, but this f2x is not a continuous function. Why? So in simple definition, if you want to define continuous function, you can say if you can draw a function from one point to the another point, not by raising your hand, you can just draw the function without raising your hand. So for example, if I draw this function, I start from here, I do not need to raise my hand, and I come to this point. So this function can be drawn without raising any hand. So this function is a continuous function. Whereas this f2x, it is not a continuous function. Why? So this function, if I draw from here, I can draw here, but now I have to raise my hand so that I can start from this point. So that means now I can draw this part. So here at this point, I have to raise my hand to draw this complete function. So here it was some jump. So this function is not a continuous function. Now in the bisection method, we have the word by means two, and we have the bisect word also in the bisection method. So bisect, as you know, it means cutting something into the two parts. So this method will actually works on this principle only. That is, it will cut some part of the answer space into two parts again and again, again and again. Or if I tell you formally, so this method is actually based on the repeated application of a theorem, which is intermediate value theorem. Now, what does this theorem means? This theorem is actually the basis for this bisection method. And this is a very simple theorem, or you can say a common sense theorem. So these are the 2 lines description of the intermediate value theorem. So let's understand first it using an example. So here you can see I have drawn a function fx on this y-axis and the x-axis. And these are the points 1, 2, 3 on the x-axis. So this theorem says if f is a continuous function, so this fx is a continuous function, okay? And it says you can take 2 points x1 and x2 on this x-axis. Okay, I will take that point, but there is one condition. You have to take those x1 and x2 which can satisfy this condition, and this condition is very important. You will see this condition in the working of the bisection method again and again. So this condition says that if I multiply the value of f of x1 and f of x2, I should get a value lesser than 0. That means a negative value. And how I can get a value less than 0 after multiplying the function value at x1 and x2? It can only happen when the f of x1 and the f of x2 values are of opposite sign. That means either f of x1 should be negative and f of x2 should be positive, or f of x1 should be positive and this f of x2 should be negative. Then only if I multiply this type of value, I can get a value lesser than 0. So I have to choose such type of x1 and x2. So if you see here, let's say if I take this as x1, that is x1 equal to 1, and x2 as 3, that means this point. Now if I check the value of this function at this 1, that means this is the value of f of x1. So this means this is f of 1, and you know that this value will be a negative value. Okay, now if you see the value of this function at this point x2 equal to 3, so this will be your f of x2. That means f of this is 3 actually. This f of 3 is actually a positive value, okay, because this is on the upside of the y-axis. So these are my valid x1 and x2. According to this theorem, this f is a continuous function, and I have taken the x1 and x2 which can satisfy this condition. Then this theorem says that there will be a point between x1 and x2 such that that point will be the root of this function. That means this f of x will cut this x-axis up at a point which will be in between x1 and x2. So here you can see this is the point 2. This can be termed as, let's say, x. So this is the point which will exist between this x1 and x2. So this is the same thing that is written here. So this f of x equal to 0 means if I put this 2 into this function, I will get the value of this function as 0. That means this 2 will be the root of this function. So the word intermediate means that there will be an intermediate value between this x1 and x2 range. So I hope you have understood this theorem, because we are going to use again and again this theorem into our working of bisection method. Now before taking a formal example or the equation to understand the working of the bisection method, let us take the overview of the bisection method. So here you can see we have a function f of x, which I have drawn here graphically, and this is the x and the y axis. So these are the 3 points on the x axis, 1, 2, 3. So here if you see, this function is not cutting this x axis on the point 2. So this is the x equal to 2. So here you can, let's say this is something like 2.5. That means 2.5 is the root of this function or the equation. So this method says first you have to find the x1 and x2, that is 2 points on the x-axis. So these points should be in such a way so that if I find the value of the function at x1, find the value of f of x2, and if I multiply them, I should get a lesser than 0 value. And this can only happen when both these values are of opposite sign. That means it can be of negative and it can be positive, or it can be positive value, or f of x2 can be a negative value. Then only I can get a lesser than 0 value. And after that I have to find the midpoint or the intermediate point between the x1 and x2. So I can just use the simple formula x1 plus x2 by 2, and let's say this new point is x. So this point x will be between the x1 and x2, and after that I have to change this x1 and x2 based on some condition, and then I will get the new value of x1 and x2. And then I will be repeatedly using these 3 steps again and again till some condition. And we will see it later that what are those conditions and all. So if I see here, this is the f of 1 and this is the x equal to 2. So the function value is this f of 2, and this f of 3 is this one. So this is a positive value, and f of 2 and f of 1 are negative value. So I can choose either 1 or 2 as the value of x1, because both f of 1 and f of 2 are the negative value. So let's say if I take x1 equal to 1, and as f of x1, that is f of 1, is a negative value, so I have to choose another x2 which can give me f of x2 equal to a positive value. So I will choose this as the x2. So I choose this as the x1 and 3 as the x2. So now this method says your root will be between the 1 and 3. That means this boundary and this boundary. Now the second step, it says that you have to, it says that you find the midpoint between these 2 points. So if I find the midpoint between 1 and 3 using this formula, I will get that 1 plus 3 by 2. That means I will get 4 upon 2, that means 2. So that means this is my new x. Now I can stop here also after finding this midpoint, and I will say this x is the my root of this equation. And if somebody says that please continue further, so I will go to this third step and I will change x1 and x2 to this x based on some condition that we will see later on. So this method says either change x1 or x2 to this x point based on some condition. So let's say I move this x1 here. So that means this will be my new x1 and x2 will remain same. So this method says, okay, this x1 and this is your new x2. These are your new boundary. So my boundary was initially this one. Now my boundary will come to this point. So my boundary has decreased. That means it was very big initially, but now it is so small. Now after finding the new x1 and x2, this method says, okay, now use this x1 and x2 and again you find the midpoint between these points. So let's say I find the midpoint between them, and let's say I got, let's say, this point. So that means I am saying you got something this as the new x. Again this method says you have to change x1 and x2. So that means this is my new x and I have to change either this x1 to x or x2 to x. So let's say I move this x2 from 3 to this point. That means this point. So that means I move my x2 here and x1 is here. So my new boundary is this one. So that means my root can now lie between x1 and x2. Now again, if I repeat this process, so again I have to find the new x between this x1 and x2. So again I find some x here, and let's say something here I find new x. So this can be something like 2.4 or something. So let's say this is something 2.4. And this process can continue till many iterations. And if somebody says just stop here, so I will say this x equal to 2.4 is the root that I found by this bisection method. So I hope you have understood about the overview of this method. So this method is again and again finding the new x1 and x2 and finding the new x, and again moving x1 and x2 to this new x, and then my boundary is getting shifted again and again, and my boundary is getting smaller and smaller, and I am finding the value of x between that boundary. And if I stop at some point, I will say that final x is my root of that equation. So finally, it's time to understand the working of the bisection method using an example. So here is this equation, and the question is you have to find the root of this equation. So I have not taken a transcendental expression, I have taken a simple algebraic expression so that we can easily understand the working of this bisection method. In place of this algebraic expression, you can get some transcendental expression involving some sin x, log x also. But the working will remain same that we will discuss here. So this question can be asked in two forms. You can be asked like find the root of this equation till 4 iteration or till the 4 correct decimal places. So what does it means? We will see it later. Our first motive is to understand what is the working of the bisection method using this example. So here I have drawn this function graphically. So this is my fx function. So this is a rough sketch of the function fx, and these are the points 1, 2, 3 on the x-axis, and here these are the value of f1. This is the value of this function at the x equal to 2 value, and here if you see this is the f of 3. So first step in the working of the bisection method is we have to find the 2 points x1 and x2 such that if we multiply the value of f of x1 into f of x2, we should get a negative value. That means these two values should be of opposite sign as we have discussed earlier. So for this you have to take some values of x and you have to try this by putting into the function. So here what I have done is I have taken the value of x as 1, 2, 3 and I have tested the values. So if I put 1 inside this function, I am getting 1 cube minus 2 into 1 minus 5. That is, I am using this function. So finally, I got minus 6. That is a negative value. And if I put 2 inside this function, so I am getting after solving as minus 1. That means again a negative value. And if I put 3, then I am getting a positive value. So as this condition says this thing only, that is after multiplying we should get a lesser than 0 value. So what are those x1 and x2 which can satisfy this condition? So let's say I can take this one and this one as my answer. That means this is a negative value and this is a positive value. That means I can take x1 as 1 and x2 as 3 also, or I can take x1 as 2 also and x2 as 3 only. So I have a choice between 1 and 2 for the value of x1. So I can take any one. So now let's say I take the value of x1 as 2 and the value of x2 as 3, right? You can take 1 also instead of 2 also. But there is a very important point to note here is that if you take x1 as 1 and x2 as 3, that means this boundary. Then to find the root of this equation, you have taken a very big boundary. So to reach to your approximate answer, you have to go through a lot of iterations. But if you take initially a smaller boundary, that means x1 as 2 and x2 as 3, then you will take lesser time to reach your approximate root of this equation or this function. So that's why I have taken x1 as 2 and x2 as 3 also. But if you take x1 as 1 also, then also you will reach to your answer, although in some more time. Now the second step is we have to find this x using this formula. So this is actually our first guess, or you can say our first approximation to find the root of this function. So I'm writing it as that I am finding the first approximation of my root. Now after finding the value of x1 and x2, I am finding the value of x, that is the intermediate point between this x1 and x2 using this formula. So what I am actually doing is I am actually taking an initial guess or a first guess to find my root between this boundary, that is x1 equal to 2 and between the x2 equal to 3, this boundary. So what I will do is I will say x1 is 2 and x2 is 3. So this will give me 5 upon 2 and this is my 2.5, and this 2.5 will lie somewhere here. Okay, although you need not to know the exact value of where this x is lying, I'm just telling you. So this will give me here, if you see, a positive value. Okay, so now you have found the x between the x1 and x2. Now third step is you have to change x1 or x2 to this x, but you have to do this based on two conditions. And what are those conditions? So these are those conditions. So this is the first condition and this is the second condition. So this condition say if you multiply the value of fx into f of x1 and this is coming as a negative value, then you have to change x2 to this x, or if you multiply f of x into f of x2 value, you are getting a lesser than 0 value, then you have to change x1. So you can change either x2 or x1 to x based on these two conditions. And in program, this will be like if or else. So any one condition will be true. So only either x1 or x2 can change. So if you see, before shifting x1 and x2, you have to apply these conditions. So here I need the value of f of x. I have the value of f of x1 and f of x2. So the f of 2 and f of 3, I have these values. But what is the value of f of x? So I will find the value of f of x before here. So I will say what is the value of this. So this value came as 5.625 and this is a positive value. So now if you check this condition, f of x, that means this value is a positive value, and f of x1, that is f of 2, this is a negative value. So if you multiply positive and a negative value, you will get a negative value. So that means whenever f of x and the f of x1, they are of opposite sign, then only this condition will be true. And same applies here. So as this condition is true, we have to change x2. And where I have to shift to the x. So that means x2 will be changed to x. And what is the value of x that I have found here? It is 2.5. And x1 will remain same, that is 2. So this is 2. So my new boundary is 2 and 2.5. So my new boundary is this one, x1 is same, but x2 has come here. So this is my new 2.5, that is x2. So my boundary is now smaller from this point to this point. So this was my first approximation, or you can say first iteration. Now I will move to the second iteration and I will take x1 as 2 and x2 as 2.5 for my second iteration. So now let's start my second approximation of the root. So again, I have to find the midpoint. After putting the values, I got 2.25. Now in the third step, you know that you have to change x1 and x2. So before that, you need the value of f of x, that is value of f of 2.25. So let's calculate that. So I got the final value as 1.89 for this value. Now in the third step, I have to change x1 and x2. So I will check both those conditions. So first, let's check this condition. So f of x into f of x1. That means f of 2.25 multiply f of x1. So f of x1 will be this f of 2. So this value is a positive value as we have calculated. And this f of 2 is a negative value as we have calculated in our previous iteration. Here you can see that this -1 is a negative value. So this will surely give me a lesser than 0 value because both these values are of opposite sign. So I will say that change x2. So I will say x2 equal to x and this will be my 2.25. That means this new x, and x1 will remain same as 2. My new boundary is 2 and 2.25. So this 2.25 will lie somewhere here. That means this will give me a positive value as it is giving me a 1.89. So this is here. So again my boundary has become this much, that is it has become smaller. So here x2 was changed or shifted. So now I will take this new value for the third iteration. So these are my new x1 and x2, and I will do this process for the bisection method for 4 iteration only, and after that I will tell you all the values that we can get if we move it to the further iteration also. So I calculated the value of x, and if I put this into the function, I got a positive value. Now I will change the x1 and x2. So to change x1 and x2, I have to check these conditions. So if I check this condition, so f of x is this one and f of x1 is this one. So this is a positive value as you can see here, and this f of 2 was a negative value. So yes, I will get a lesser than 0 value. So this condition is satisfied and this says that you have to change x2 equal to x. So that means again my x2 will change. So x2 will come to this value, that is 2.125, and x1 will remain same as 2. So that means previously x1 and x2 was something like that, and now x2 will come here. So my new boundary has again become smaller. Now I will move to the fourth iteration and I will take these x1 and x2 values for the fourth iteration. So again I come to the fourth approximation of the root and I found the x. So this is my x, and the value of f of x is a negative value now. Earlier it was coming as positive value and now it is a negative value. So something different will happen other than the previous iteration. So let's see. So now I have to change x1 or x2. For that, let's check these values, and f of x is a negative value and f of x1, that is f of 2, it was again a negative value. So that means multiplying two negative value will give me a greater than 0 value. That means this condition is wrong. But if I check this condition, it will be true because this f of x, that means this value is a negative value, and f of x2, that means f of 2.125. If you check it, f of 2.125, it was a positive value. That means this is a positive value. So multiplying two opposite sign value, I will get a lesser than 0 value. So that means here now x1 will change according to this condition. So x1 equal to x and it will be 2.0625 and x2 will remain same. So here my x1 was changed. Earlier it was x2 which was getting changed. So this is something like x1 was here, x2 was here. Now x1 come to x point and now my boundary again shifted. So if somebody would have said that you have to go till 4 iteration only. So what I would have done is I would stop at this point only. That is, I find the value of x and I will say this is my final value of the root for this equation. So I will say 2.0625 is my final answer. But if somebody said that you have to go to the further iterations also, so you can repeat this process again and again. So now we will not go further. I will just tell you if I go to the more iteration, what can be the value of x1 and x2 or the root of the equation. So here if you see this table, here this n is the iteration number. So this is the first, second, third iteration and so on. And these are the value of x1 and x2 and so on. So initially we take x1 as 2 and x2 as 3. Then we find the x as this formula and we got 2.125. And this was f of x. And in the first iteration, x2 was changing. So what we did, we said for the next iteration, that is second iteration, the value of x2 is going to the x. That means now this is my new x1 and this is my new x2. And again, I repeat the process. I got x as 2.25. And here my x2 was changing. So this x came here. And in the third iteration, these were my new boundaries of x1 and x2. And again, in this process, x2 was changing. So this x was getting into x2. And if you see in the fourth iteration, this was x that I was getting. And here x1 was getting changed. So if you repeat this process, let's say till 14th iteration. And if you stop here in the 14th iteration, you got 2.094481. And this is my final root if I stop at the 14th iteration. So now we will see a C program which can implement this bisection method. And I will tell you two versions of the bisection method. First, I will tell you a simple version of the bisection method. And after that, I will tell you the another version of the bisection method where I will introduce about the error also or the threshold. So this is the simple pseudocode for our bisection method. So just before explaining this bisection method pseudocode, I will tell you how our output will look like. So I have written the source code for the bisection method in the C program, and I am just running this program, and let's see how our output should look like. So here I have run the program and it is asking me, just tell me enter maximum number of iteration. That is, you have to tell that how many times you want to run the process of the bisection method again and again. So you have to tell the maximum number of iteration. So let's say I tell that run this process 16 times of the bisection method. Then it will ask me what are the initial values of x1 and x2. So let's say if I enter 2 and 3 as I discussed, so I will get this type of answer. First message is root lie between 2 and 3. It is optional. You can just print this or not. And after that, you can see I am getting many intermediate answer. That is, in iteration 1, I am getting root as 2.5. In iteration 2, I am getting 2.25 as the answer. So actually, I have used the same equation that I have shown to you in the discussion. So at last, after 16 iteration, I am getting 2.094559 as the root value. So this is my final root value after the 16 iterations. So this type of output I want in my first version of this bisection method. Now it is up to you. You want to print this intermediate value or not, but it is a good practice that you print the intermediate value also. Now let's say if I run this program again, and if I enter, let's say 16 iteration, but if I enter x1 as 1 and x2 as 2, and as you know, at f of 1 and f of 2, you will get the negative value of for this function. So that means these x1 and x2 will not satisfy f of x1 multiply f of x2 less than 0 value, because these f of 1 and f of 2 are of same sign. So these are invalid values of x1 and x2. So I should get root are invalid. And again, my program should ask x1 and x2 values. So let's say if I enter again 1 and 2, so again it should say roots are invalid. So again, it should ask me the correct values. So let's say now if I enter 2 and 3, then it will show me the final result. So now let's understand this pseudocode. So as I told you, you have to enter x1 and x2 and the value of n, that is maximum number of iteration. And after that, in a loop, you can just ask the user, please enter x1 and x2 till the point this condition is getting. That means if you are getting this x1 and x2 multiplication is greater than 0 value, you have to ask again, please enter correct x1 and x2. So let's say you got some correct value of x1 and x2 from this part. Now you have to just do this looping. That means you have to run a loop from I equal to 1 to maximum number of iteration. And you have to repeat just these steps again and again. So you find the value of this x using this formula as we discussed. And after that, we have to shift x1 or x2. So if this condition is satisfied, as we discussed, you have to change x2. And if this condition is satisfied, you have to change x1. So after changing either x1 or x2, you have to just say I++ so that you move to the next iteration. Now you can write here the another condition if you want, something like else if this condition less than 0, and then this thing. Then this will also be correct. This process will go to till maximum number of iteration, that is till n, and after that you have to just print the x value, that is your root value. Now one important thing that I want to tell you is, if you take wrong value of x1 and x2, let's say if you take x1 as 1 and x2 as 2, then you will be finding the root between these 1 and 2 only. And there is no root between 1 and 2 for this function. So you will keep on going again and again into a, let's say, infinite iterations or infinite process. So you have to take the correct values of the x1 and x2 initially by checking this condition correctly. The next thing is, why are you changing x2 when this condition is true? And why are you changing x1 when this condition is true? Why not here x1 and here x2? So here if you can see, this is my x1 and this is my x2 initially. And when I found the midpoint, I got 2.5, this one. And this first iteration, this condition was getting true, I was changing x2. So that means I was changing 3 to 2.5. Let's say if I change x1 here, so that means this 2 will come at 2.5 and my new boundary will be 2.5 and 3. That means in the second iteration, I will take this boundary and I will find the root between 2.5 and 3. And you know that there is no point that you can find between 2.5, 3, which can be the value of this function as the root. So that means you will again go to an infinite loop, or you can say infinite process of the iteration without getting any correct value of the root. So that's why here you will change this x2 to 2.5, not x1. So now let's see the C program for this bisection method. So this is our program, and these are two functions that I have used in our program. So for the time being, let's start from this main function. So I have taken a variable max iteration, which was actually written as n in our pseudocode. So this is our maximum iteration variable, and I is starting from 1. Next, I have taken x1 and x2, and the third variable is x. So my first input will be maximum iteration, as we have discussed. Now, in a do-while loop, you will ask x1 and x2 values again and again till this condition is true. That means you will ask the value of x1 and x2, and if this condition is true, that means you are getting a greater than 0 value. After multiplying this, you will say roots are invalid and you continue and again ask the value of x1 and x2. But if this condition is false, that means value of function at x1 and x2 are of opposite sign. That means you come to else and you will say root will lie between the x1 and x2, and you will come out of this break and you will come out of this do while loop. So here I have written while 1, that is this is an infinite loop, but you will come out when this break is satisfied. Now next question is, what is this find value at, which will take a parameter or the value of x and it will return me the function value at that particular x point. So if you see the definition of this function, so this function is containing the equation actually. So this is accepting a value of x and it is returning a float value. So this is our equation, x cube minus 2x minus 5. So this x is putting in this equation and the answer is getting returned. So whatever equation you want to put, you can just write in this function body. So now our this do while loop has given us the final value of x1 and x2. Now in the next while loop, we are repeating the process of the bisection method again and again. So while I is less than max iteration, we are just finding the midpoint using a function bisect, and after that we are checking if an else if condition to change or shift the value of x2 and x1. And after that I am just printing the intermediate value of the roots and I'm saying I plus plus so that we can move to the next iteration. And after this while loop gets end, we are printing the final value of the root. So if you see what will be the return inside this bisect method. So here you can see we are accepting two values x1 and x2 inside this bisect method, and it is finding the midpoint and it is returning that. And why I have written here minus minus I outside this while loop, why not I? Because when this loop will gets over, let's say we say max iteration as 5, so this loop will get over at the 6th iteration when I equal to 6. So but we want to print here 5, so we will say minus minus I. So 6 will be decremented to 5. Then only we can print that at 5th iteration I am getting this root. So if I run this program, it is asking me maximum number of iteration. I said 16 times you should run this bisection method. I said 2 and 3 are the value of x1 and x2. So here I am getting the intermediate value of x1 and x2. And finally, I am getting this as the root equal to 2.094559. So I hope you have understood this program. So now let's move to the another version of this bisection method. So we have seen the first version of this bisection method, that is how we can run our bisection process till some iteration. Now let's move to this second version. So here we are said that you have to find this root of this equation till your 4 correct decimal places. So what does it mean? So let's say if question would have asked that you have to repeat this process till 2 correct decimal places, then what is meant by that? So actually what it means, for example, you are on the 6th iteration and you are getting value of x as this one. In the 7th iteration, you are getting this one. So in 6th and 7th, if you see after decimal point, you are getting 1 0. Here also you are getting 1 0. So both these two digits after dot, you are getting same values 1 0 1 0. So here you will stop your process of this bisection method and you will say this value and this value has same decimal values after dot, that is 1 0 and 1 0 are same. So you will stop your process and you will say this is my final value of x. The same way the question can ask repeat this process till all the 4 digits after this dot gets same. So that means, for example, here you are getting 2.0945 and here 2.094481. So let's say instead of this, here in the 14th iteration you would have got 2.0945. So here the 4 values and here 4 values after dot point are same. So you will say at 14th iteration I will stop. Now if you see here it was 0.945, but here it was 0.944. That means here it is 5, here it is 4. These are not same. So this is also possible that you may not have the exact match between these decimal values. So what you will do here is or allowed error. So what does it mean? It means that if you subtract this value of x and this value of x, that is previous iteration value of x and the x value that you are getting in the current iteration, if you subtract them, you get some difference value. So that will be the error actually between these two iterations value of x. And if that difference or the error is less than this allowed error, then means you will stop at that point. That means that much of error or the difference you can tolerate. So this concept we will use in our second version of C program. And how this allowed error will be computed. So it simply means, for example, if you have to find the match between the 4 decimal values, then what you will do is this allowed error will be 0.0001. And if you want to find the match between 3 decimal values, then this allowed error will be 0.001. The same way for 2 decimal values match, you will say 0.01 as the allowed error. And this allowed error is sometimes called as epsilon. You should also know this terminology if somebody is using this terminology. So let's see our second version of our program. So this is our second version. So this is my second version. So this code is almost similar to this first code. So I have just added this code and most of the code is similar. So this code will remain same here. That is, I have to ask the value of x1 and x2 and n, and this loop will remain same. Now after that, as you know, in this second version, we have to find the difference between the previous value of the x of the previous iteration and the current x of the current iteration. So we have to take care of the previous value of x also. So what we have done is we have find the value of x. So let's say some value of x has come. Now in this do while loop, what we are doing is we are checking this condition. So either x1 or x2 will get shifted as earlier. Now again we are finding the bisector point from the changed x1 and x2. So we will get a new x, and here I have saved into the x3, not in the x. So now I have x3 and the x. So this is my previous iteration x and this is my current x3 for the newer iteration. So now I will find the difference between this. So absolute error will be found, and if it is lesser than this allowed error, this is my allowed error, then I will say this x is my final answer. You can also print here x3 also, and I will say return. So these two lines are inside if. So we can say our x1 and x2 were something at this boundary. My x1 would have shifted something here by finding the x. So this will be my new x1 and this will be my new x2. So if this condition is not true, I am saying that x equal to x3. And I will tell you why we are doing this. Let's say if this line is not there, we just say move to the next iteration. So here if you come, then what will be the value of the x? So if this line is not present, then that means this value of x is same as this one. So this process will again go on. And now if you see inside this code, you are not changing the value of x. That means this x will remain same as this one. So it means your x1 and x2 will never change now. And you will say that your boundary will remain same again and again, again and again. That means you will something like going into the infinite loop. So this condition or this line is very much essential. You have to change the value of x. So x will be changed to the new x3, this x3. So this newer x will come here and then x1 and x2 will be getting changed. So this process will keep on going, and after that you can print x if this loop gets over. So that means you can come out of this loop due to two conditions. Either your this condition is true, then you can come out before your maximum iteration is reached, or you can come out if you have exceeded your iteration. So now let's see the C program for this version. So these two functions are same as previous, and here in the main function we have the same thing, maximum iteration and sum of the variable, and we have asked the maximum iteration, and this do while loop is same as previous, and this is the same as we have discussed in the pseudocode. Here we have find the bisector point, here we have shifted the x1 and x2, and here again we have find the bisector point, and we are finding the difference between x3 and x, which is less than this epsilon. And what is this epsilon? So I have taken a macro. So here it is my macro, and what is the value of this macro? It is 0.001, because I am finding the match between the four significant figure. And if you are asked that you have to find the answer till two correct decimal places, then you can just change as this as 0.01. So it depends on you what is the question asking. And you can also write the value of epsilon or the allowed error here directly. But it is a good practice that you should make some constant thing as a macro. And here I have taken a FABS function because difference of x3 and x will be a floating value. So I have taken a FABS function. So here f means floating. That means find the absolute value of a floating argument. So let's run this program. Let's say if I enter 16 as the maximum number of iteration, value of x1 and x2 as 2 and 3 which are valid. So here I am getting the values of the roots in all the iteration, and finally in the 13th iteration I am getting this root as the final answer. So here if you see, we have not gone to the 16th iteration. We have come out after the 13th iteration and we have said this is my final answer. That means my difference will be less than my epsilon. So I just printed this answer and I just exited my program. So I think you have understood the concept and the theory behind the bisection method, and you have also understood how you can write the C program to implement the bisection method. So if you have any queries, comment or suggestion, please write down into the comment box. And if you are new to my channel, you can subscribe my channel and you can press the bell icon for further notification. See you in the next video. Till then, goodbye.